This video covers setting up your envelope parameters for analysis in Sefaira's web application. It applies to both Sefaira architecture and Sefaira systems. We're going to be exploring the Envelope tab, the first input tab in the input section of the web interface. Often a good place to start your analysis is with a baseline input by selecting from one of the predefined baselines that you see from this dropdown. Code such as ASHRAE 90.1 and CPSI Part L will specify specific minimum values for the building envelope, and that allows you to start out with a reasonable baseline or reasonable starting point without a whole lot of setup work. Now you can find all of the assumptions that go into each of those baselines in the Sefaira knowledge base under General Information and Baselines. Here you can actually also find values for many more standard baselines from all over the world. So if you don't see the one that you're looking for in that dropdown, I recommend coming to this part of the knowledge base, and you might be able to get a baseline set up very quickly from here. One general note is that you'll notice that the inputs in this tab are fairly broad brush. For example, Sefaira doesn't ask you to define wall assemblies, just the kind of overall thermal mass and R-value characteristics instead. And this broad brush nature is intentional. Sefaira is designed as an early stage tool, meant primarily for target setting and comparative analysis to guide design decisions. So it's designed to answer questions such as, what should my R value be? Or how much benefit does increasing the R value of my wall have for this building? Rather than questions like, given this series of fully designed wall assemblies, what is my energy use? So let's go through each of these cards, which each defines a certain element of the building envelope. The first is facade glazing, and you can control the overall assembly U value of the glass. The lower the U value, the better insulation, as well as the solar heat gain coefficient. The higher that value is, the more solar gain the glass lets in. I should also mention that you can control many of these input values either on a whole building basis, which is what you're seeing here, or if you toggle this Collections tab, you can control these properties on an orientation by orientation basis. So this can be very helpful for things like the solar heat gain coefficient, where you might need to have a much lower solar heat gain on the east and west facades than you do on the north. And you can control those by adjusting the inputs in each facade independently. This is also a good place to point out response curves, which is a feature that we'll discuss more in other videos. But just as a brief introduction, you'll see a little graph icon pop up next to each of these inputs. And if you click on that, what you'll be able to do is run a series of simulations across a range for that specific input. For instance, we could test the impact of changing the solar heat gain coefficient of our windows from 0.1 all the way up to 0.9. And we can test the impact that that has on a range of outputs. For instance, let's take a look at the impact that has on the overall energy use per square foot of the building, and perhaps on the highest peak cooling load. So what we can see here is that from an energy standpoint, that's the line in yellow, there is an optimum for our solar heat gain coefficient of our glass. And then on the red line, we can see that there's a fairly linear relationship between the highest peak cooling load and our solar heat gain coefficient. So this is one of the ways that Sefaira allows you to test these variables and figure out what should the design be targeting for each one. All right. Next to the facade glazing, you'll see an option for override the window to wall ratio. And this allows you to actually ignore, essentially, the glass that is modeled in the 3D model and specify on a percentage basis the window to wall ratio for each facade or for the building overall, depending on if you are adjusting on a facade by facade basis. So you would simply turn this on and type in the ratio that you want to model into this box. Next is properties of the walls. There are two inputs here. One is the assembly type. This controls the thermal mass characteristics of the wall. So you might have a very light wall like stud framing with little mass, or something like concrete block that has much more. If you're interested in seeing what the kind of schematic assemblies are that are assumed when you choose each of these, you can actually follow the link in this tooltip to learn more. The other input is the overall R value of the walls. So this is the assembly R value. And again, you can adjust this on a per facade basis as well as an overall basis. And if you have multiple assemblies, you'll need to calculate a weighted average to put in here. But again, the intent is really to help you define what that target should be and how impactful it is. Next is floors. The floor finish determines how heat radiates back into the space, so you can choose some carpet, tiles, or hardwood. And the ground floor R value is essentially the sub-slab R value, the R value of the floor that is in contact with the ground surface. Below that is infiltration. Now, depending on the code or standard that you're using, you may measure infiltration into the building in different ways. You can measure it in terms of air changes, in terms of CFM per facade area, or perhaps in terms of crack infiltration. And that is the perimeter of openings through the envelope, like windows and doors. So you can input the infiltration for your building in any of those ways. Below that is roof glazing. Now this only applies if you have skylights or glazing in roof surfaces in your model. And here you can adjust the same two properties of glass that you saw above, the U value, the insulating properties, and the solar heat gain coefficient properties. If you don't have any skylights or roof glazing, you don't have to worry about this input. And below that is properties of the roofs. The roof type, again, controls the thermal mass characteristics of the assembly. And the roof R value controls the overall R value of that assembly. And once again, if you want to understand the schematic assembly that's going into this thermal mass calculation, you can follow the tooltip link. And then finally, you see a tab that allows you to adjust the orientation of the building. And again, this is probably a good use of response curves, where you can very early on test the impact that rotating the building has and determine if there's an optimal orientation. And that's it. That is the envelope tab.